So here's one specific example. You want to identify the transformations, you want to apply any stretch or compression to the table, and use the translations to figure out where to start the vertex. So what I typically do is look at the equation and identify what translations are happening from what. So that 2 multiplier on the outside will stretch our parent function vertically by a factor of 2. And basically the way I think of that is all the heights off of the vertex will be twice as tall. I'll get into that in a second. So if those are the y values for the parent function, those y values are all now doubled. And then the -3 on the outside, subtracting 3 will translate it or slide it down 3 units. So the multiplication out here basically is vertically stretching it, and then the -3 is taking this and sliding it down 3 units. So to graph it, we start by thinking where the vertex point, that's this point here, will end up on the graph. Oh, forgot I said that. All right, so now there's your parent function. The shifting it down 3 will move that parent function down 3 units. And the, I guess you could have stretched it, then slid it, or slide it, then stretch it, but the result is the same here. All the heights now, instead of being where they were, this is only a height of 1, this is only a height of 2 off of the vertex, it's a height of 3 off of the vertex. Now we're at height of 2, height of 4, height of 6. Whoops. And that gives us that final image. So this is all the slope basically is twice as steep, and the vertex has been shifted down. Now we didn't do every transformation. We could have slid it left or right or flipped it, and you'll do that in the practice.